Hello, you're welcome. All right, indices and logarithm. Okay, so this is a two-in-one topic. So we start with indices. All right, what's indices? Now, indices is simply the plural form of index. Okay, so it's the plural form of index. So now, the question now is what is an index? All right, an index is simply an index number is actually a number. Okay, expressed in exponential form. Excuse me, a number in an exponent. So any number in an exponent is called an index. For example, okay, 2 raised to the power 3 is an index. All right, it's an index. The 3 here is the power of the index, while the 2 is the base. Okay, the power, or you call it the exponent. So 3 is the exponent of 2, 2 is the base. Now, please, you should note that 2 raised to the power 3 is this is not 2 times 3, but rather it is 2 times 2 times 2. So please take note of that. And if it is, let's say 2 raised to the power 5, it's never 2 times 5, okay? It's 2 times 2 times 2 times 2, okay? Then times 2 into 5 times. Of course, this gives you 8, and this gives you 32. All right, so now for us to be able to um, solve question in indices, okay, very well, we need to actually know, okay, study the laws of indices. So laws of indices, it is the correct application of these laws that will help you to solve question in indices correctly. So we're going to be looking at these laws, and you should take note of them. So let's start with the very first law. Now each of these laws I'll be giving you, I will give it a name so that you always reference it by the name. Okay, I call this law addition law. Okay, it goes this way. If I have a raised power m, then times a raised power n. These are two indices, all right, but they have a common base, and the common base is a, and they're multiplying each other. So this law, which is called addition law, says that we'll only write one of the base, then we'll add the powers. So that is why I call it addition law, because multiplication of two indices, okay, led to the addition of power. So you just reference it with by addition law, okay, so that when we use it, we always remember it by addition law. Then number 2, I call the second difference law, because here I'm having a raised power m, then divided by a raised power n. Okay, so what will be the result? It's going to be a, then m, because of the division, then the powers are subtract the power, that's m minus n. All right, I hope you are taking note of the law. The third law, I call it power law. Power law simply means that if you have an index, remember an index already have power, let's say a raised power m, then I now raise it to another power, okay? So it simply means that the powers of an index, this law states that the powers of an index, okay, will always multiply themselves. So the power outside the bracket will always multiply the power inside the bracket. So this is something as a raised power of m times n, okay? This is power law, so please take note of that. Okay, the next law I'm going to introduce, law number 4, is I call it reciprocal law. What's reciprocal? Anytime you have an index having negative power, okay, it's called reciprocal. Now, how do I evaluate the reciprocal? It simply means that I will do 1 all over. If I want to remove the minus power, okay, I will just do reciprocal 1 all over A, then of course raised power n. So when you invert an index that's having a negative power, you call it reciprocal, the negative sign will disappear. And vice versa, okay? If I have 1 over a raised power n and I want to bring it up, okay, then the power now becomes negative. For example, if I have 2 raised power minus 3, this is equivalent to 1 all over 2 raised power 3, okay, which of course is 1 all over 8. Okay, so I hope that's well understood. Then number 5 law. Number 5 law, I call it root law. Okay, that is an index inside a root. And the root is not just square root, okay? It can be any root. It can be square root, it can be cube root, it can be fourth root, fifth root. So this m represents a root. Okay, let's say you have an index. Okay, a raised power m inside the root. Now this root can be converted to power. So I'm going to have a raised power m, but the power now is going to be a reciprocal power. So that is, so if I want to do this now, invariably now all I just need to do is, okay, the whole index will now have a power, okay, which of course is the reciprocal of, okay, the root, be it square root, cube root, fourth root. For example, if I have cube root of 27, okay, and of course you know very well that 27 as an index is 3 raised power 3, okay. You know that now 3 times 3 is 9, 9 times 3 is 27. So now applying the root law, now I can now do this 3 raised power 3, then the root now becomes 1 over 3. And of course 3 times 1 over 3, 3 cancels 3, so I'm left with just 3. So that is it. Okay, so now is there another law? Okay, all right, if there is other law, I will still bring it, okay, as we progress in the tutorial. But let's start applying the laws. So the very first thing I'm going to do now is to bring example. Okay, let's see how this law can be applied. Okay, so let's look at this. Evaluate. Okay, a 2 raised power of n minus 1 times 8 raised power n divided by 16 raised power of n minus 2. B, the cube root of 8x raised to the power of minus 3 all over 27. Okay, so let's just do justice to this as we look at more questions. Starting with this solution. Now you know very well that by seeing this multiplication here and by seeing this division, one thing that should come to your mind is addition and of course difference law. Okay, but I can apply addition law, okay, between these two indices. This is already 2 raised power n minus 1, but this is in base 8. Before I can apply multiplication law between two indices, okay, they must be on the same base. So that means I have to convert this 8 raised power n into an index, okay. I know very well that 8 is 2 times 2 times 2, right? So already we know that 8 is 2 raised power 3. So that's exactly how I'm going to convert this to that. So I'm now having 2 raised power n. I'm working on a now, okay? 2 raised power n minus 1, then multiply by 2 raised power 3, okay? And then all over, I'll do the same to 16, okay? Change it to an index That's going to be 2 raised to power 4. Okay, 2 raised to power 4. Then there is already power. So for the, if you know, power will always multiply power. So 2 raised to power 4, then multiply by the power that was already there, minus 2. Okay, so I'm done with that. So I can now apply the addition law, and you know what addition law says. Okay, I will have to add the powers. I'll write one of the base, then I'll add the powers. Then divided by, of course, 2 raised to power, let me open this bracket, 4n, 4 times minus 2, that's going to give me minus 8. I've opened this bracket. Now this is going to be equal to, of course, collecting like terms together, n plus 3n, that gives me 4n. Okay, so I'm having 2 raised to power 4n minus 1. Okay, then of course divided by, I can use this division sign, divided by 2 raised to power 4n minus 8. So at this point now I can apply the other law. Okay, so what's the other law? The difference law, because of the division now. So I have 2 raised to power 4n minus 1. Then of course, because of the division, I have to subtract the power, minus into, okay, the other power, 5n minus 8. Remember difference law. Okay, you write one base, then you now subtract the powers. Now you see, as you notice here, I have to put bracket after I've introduced the minus. The reason being that minus, okay, this minus, the difference that's going to be is minus all the powers, not just one power. And anytime minus is actually is in front of more than expression, one expression, okay, minus have the ability of affecting every expression. If the expression is positive, it will become negative if it is negative. So that means anytime I have minus in front of, okay, any expression that's actually act as 1, because 4n minus 8 act as 1 because 2 of them are the power of 2. All right, so I have to group them inside a bracket, so that by the time I open this bracket, I will actually effect the changes that this minus actually brought. Okay, so please take note of that. So this is going to be equal to 2 raised to the power of 4n minus 1. Then minus into 4n, definitely that's going to be minus 4n. Minus into minus 8, that's going to be plus 8. So collecting like terms, you know very well, 4n minus 4n, they are like term. Okay, 4n minus 4 minus 4n, that gives me 0. So I'm left with minus 8 plus 8. And of course, minus 8 plus 8 is 7. So I'm having 2 raised to the power 7. Okay, and if I do 2 raised to the power 7 with calculator, 2 then raised to the power of, okay, where's my raised to the power? Okay, so let's do times 2 times 2 times 2 times 2, that's 32 now. That's times 2, 64 times 2, that's 128. So 2 raised to the power 7 is 128. Okay, yeah. Oh, please pardon me. That's 128, not 2 raised to the power 128 again. So this 128. Okay, as my final answer. All right, so that is that for that question. Let's look at the second part of the question. Okay, let's see how we can apply the laws of indices to solve the second part of the question. So I clean up. Okay, so let's go there. So here I'm having now the cube root of 8 s raised to the power minus 3, then divided by 27. So if I ask you which law are you going to apply here, the law I'm applying here is the root law. Remember the root law. So I told you, okay, in the root law, Okay, the root now becomes a power, reciprocal power. So I'm going to have x raised power, or rather in this is s 8x raised power minus 3, then divided by 27. Then because of the root now becomes reciprocal of the powers. Okay, so this is going to be equal to, remember I have to, okay, express the 8 as an index, and 8 is something as 2 raised power 3. Okay, then of course x raised power minus 3 is already an index form. Then 27, you will have 3 raised to the power of 3. Okay, then I have to close the bracket, and of course still write down my power outside the bracket. So at this point now, what I'm applying is power law. Power outside the bracket will always multiply with the power inside the bracket. So remember a power law, okay? Power always multiply themselves. So if I open this bracket, then this power outside the bracket will multiply all the power inside the bracket. So I'm gonna have 2 raised power 3, okay, times 1 all over 3, then times x raised to the power of minus 3 times 1 all over 3, all divided by 3 raised to the power 3 times 1 all over 3. So at the end of the day now, 3 cancels 3. Okay, 3 cancels 3 here, then 3 cancels 3 here. So I have 2 left. Okay, then of course here this is minus 1, then x raised to the power minus 1, then of course 3 raised to the power 1, which of course is 3. So at the end of the day now, my answer now is going to be equal to 2. Okay, then x raised to the power minus 1, reciprocal, remember reciprocal. So if I want to remove the minus, I have to do the reciprocal of x. That means x now will now come down into the denominator. That's going to be what? Okay, 2 all over 3x. So this is my final answer. Okay, so this is how we apply the laws of indices, and I'm still going to apply more laws. Okay, I'm gonna solve more examples so that you understand how we apply the laws of indices. Okay, see you in the next video. Thank you very much.